Hi everyone and welcome back. We're looking at another question from the homework, page 83, number 13. We are on Unit 1, Rates of Change, and we're reviewing for the unit test. Let's read the question together. Tangents are drawn to the parabola y equals x squared. I'll write this down. And the tangents are drawn at 2, 4 and negative 8, 1 over 64. Wait a second. So we have 2 points where we're drawing tangents. One is point, and I'll give it a name, point A, and the other one is the point B with coordinates negative 8, 1 over 8 and 1 over 64. And as you can see, the coordinates of the points given fit into the equation because these 2 points are on the graph of this equation. Now, provided the lines are perpendicular, so the lines we're talking about are the tangent drawn at 2, 4 and the tangent drawn at negative 1 over 8, 1/64. So we're going to say that the tangent drawn at A, remember A is a point on the parabola, would be perpendicular to the tangent drawn at B. So if you want to prove that 2 lines are perpendicular to each other, what do we have to do? So that's the first question that we need to think of. So two tangents or 2 straight lines are perpendicular if their slopes are negative reciprocals of each other. So what that means is that we need to find the slope drawn at A and the slope drawn at the point B. And to find the slope, we also know that it means to find the derivative. So we're going to say that dy dx at A must be the same as dy dx drawn at, or the slope of the tangent drawn at B. So we have to get started by finding the values of dy dx, or the derivative of this function, at these 2 specific points. So let's get started with differentiating y equals x squared. So the derivative would be dy dx equals 2x. Remember, you don't have to use first principles if you're not asked to, because first principles is the longest, well, and the most analytical way of finding the derivative, but we don't want to do that if we're not asked to, because it's a very lengthy and complicated process. And I've seen people do that all the time on the test, and it takes so much time, and using the time efficiently during an evaluation is very, very important. So here we are. We now know dy dx equals 2x. Now, what is the meaning of it? It means that the speed of change of the y values in this function at any point x with coordinate x equal to this one here would be equal to 2x. So what does that mean to the rest of the problem here? So if we want to find out what the derivative is exactly at x equals 2, that means that we have to substitute x by 2. So we're going to say that the derivative will be 2 times 2, which equals 4. Now, at x equals negative 1 over 8, the derivative would be equal to, again, since the derivative is 2 times x, at x equals negative 1 over 8 will be 2 times negative 1 over 8. That will make it negative 1 over 4. So therefore, we're going to say that the slope of the tangent at A will have a value of 4. So the slope at A would be 4. And the slope of the tangent drawn at B will be negative 1 over 4. So if you compare these 2 numbers, they're negative reciprocals of each other, which means that the 2 lines with the respective slopes will be perpendicular to each other. And with this, we have answered the question that the lines are perpendicular. Now we're asked to illustrate this with a sketch, and we will do this by using Desmos. So let's take a look at Desmos. So we are going to draw the graph y equals x squared. How hard is that? So here we go, y equals x to the power 2, and bam, we got our parabola. So in order to draw the graph, we're going to need to go all the way to negative 1 over 8. And what I'm going to do to make this, as easy to see as possible is I am going to draw a parabola at a nicer scale here. Okay, I think that we can see the two sort of now, because I need to fit both the negative 1/8 and the value of the function at 2 here. I think that we are at a good point here. All right, so let's take a look and let's see what it looks like. I wanted to do this because it's easier to kind of have a better view of the graph, because it's very easy to create rooms for a misinterpretation here. So it's kind of nicer to have a precise graph. Here we go. So negative 1/8, that's the point where you're drawing the tangent. So if this is 1 unit, then we're taking 1/8 of it. So we have 1, 2, 3, 4, 5 squares. So that means this would be a quarter. So 1/8 is half of a quarter, so it will be a point somewhere in here. So let's draw a tangent to the best we can at this very point. That would be the pink one. So, okay, let's see. I'm telling you, it's not going to be that easy because it's a point way down on the graph. Okay. All right, so I think this is good enough. And when you go at x equals 2, which is somewhere in here, let's try to draw a tangent line. You can kind of see that the two lines will be almost perpendicular in here if we continued. So you can see that this answer does make sense in a way. So I hope you found this useful, and thank you for watching. Bye for now.